Here I am going to explain binomial distribution. First of all, why we need binomial distribution? Let us we see with two examples. Example number 1. If a coin is tossed 2 times, then find the probability of getting exactly 2 heads. Second example is if a die is thrown 1 time, then find the probability of getting 6. Observe these two examples carefully. The number of trials in each experiment is less, means very small. In the first example, the total outcomes in this experiment is 2 square, that is equals to 4. Those are HH, HT, TH and TT. So in this I am going to find probability exactly 2 heads. Here exactly 2 heads case is only one, that is HH. Out of 4 there is only one possibility. So probability of x is equal to 2 is 1 by 4, means here 2 is exactly 2 heads. In the second example, if a die is thrown 2 times, suppose there is 2 times, then the outcomes in this experiment is 6 square, that is equal to 36. Write all 36 possible outcomes in this experiment. Like example number 1, we will find easily the required probability. But in some special cases or some examples, if a coin is tossed 20 times, then find the probability of getting exactly 3 heads. And one more example is if a die is thrown 10 times, then probability of getting 6 exactly 5 times. Observe these two examples carefully. Here the number of trials are very large, means coin can be tossed 20 times in third example, and fourth one is 10 times. So in such cases we want to find the required probability by using binomial distribution. What are the properties of binomial distribution? Let us know. The first property is experiment should be conducted n trials. So suppose a coin experiment can be conducted 3 times or 4 times or 5 times like this. Here 3 or 4 or 5 is equals to n. And the second property is each trial should be independent. Each trial should be independent. So, and third property is each trial has two outcomes, that is success or failure. Success or failure. Fourth property is the probability of success or failure in n trials is denoted by, that is P of success is equal to small p, P of failure is equal to small q. Therefore, P plus Q equals to 1, that implies P equals to 1 minus Q, or Q equals to 1 minus P. The fifth point is the random variable x represent number of success in n trials. Number of success in n trials. So the second property can be extended identical also. So suppose an experiment can be conducted n trials like 1, 2, 3 and so on n. In each trial there is two possibilities, success, failure, like this. So in each trial success is same. So this means identical. So conducting experiment n times, we want to find the number of success. X in NCX ways. Out of n trials, there are x are success, remaining n minus x are failures. Here the probability of success in n trials is x, that is p power x. The probability of failures is n minus x, that is q power n minus x. This is probability mass function formula in binomial distribution. So p of x is equal to small x is equal to ncx, p power x, q power n minus x is the probability mass function of binomial distribution. Here n and p are the unknown parameters. Why? Because these two are unknown parameters. By knowing the value of p here, we find easily q value, and we knowing the value of n here, we easily find the required probability by using this formula. So it is denoted by x follows b of n comma p. Here n comma p are the constraints, unknown parameters. So what is the mean value in binomial distribution is np, and what is the variance value in binomial distribution is npq. There is a relation between mean and variance. Mean by variance is equals to np by npq. Np cancel, 1 by q, it is greater than 1. So mean is always greater than 1. Here p of x is equal to small x is the probability mass function formula. Np is the mean, npq is the variance, x follows b of n comma p is the notation. Mean and variance relation is like this. If mean value is 7 and variance value is 8, observe this, mean value is less than the variance value. The binomial distribution does not exist in this case.